Hi, I'm James De Mendez and welcome to my channel. Today, we'll be discussing mathematics in the real world, data management, geometric design, and lastly, the mathematical system. Mathematics in the real world. How is math used in the real world? Math helps you build things, figuring the total amount of concrete needed for a slab, accurately measuring lengths, widths, and angles, and estimating project costs are just a few of the many cases in which math is necessary for real-life home improvement projects. The importance of mathematics in real world is that math helps us have better problem-solving skills. It helps us think analytically and have better reasoning abilities. Reasoning is our ability to think logically about the situation. Analytical and reasoning skills are essential because they help us solve problems and look for solutions. Data management. Data management is the process of ingesting, storing, organizing, and maintaining the data created and collected. Data management can also apply in the field of mathematics that are useful in processing and managing numerical data and describe phenomena and predict values. There are 5 compositions of data management, which are the following: measures of central tendency, measures of dispersion, measures of relative position, probability and normal distribution, correlation and regression. First is the measures of central tendency. It defines as a summary statistic that represents the center point of typical value of dataset. There are 3 common measures of central tendency are the mean, median, and mode. Mean is the most efficient measure of central tendency for normal distributions. Median is useful because it's more efficient and it has a clear meaning. It ignores many scores and generally less efficient than the mean. Mode defines as a number of dataset from least to greatest, and the number that occurs the most is the mode. Second is measure of dispersion. It shows the scatterings of the data that tells the variation of the data from one another as a result of how much data vary from their average value. Third is measures of relative position. Statisticians talk about the position of value relative to other values in a set of data. The most common measures of positions are percentiles, quartiles, and standard scores or z-scores. Fourth is probability and normal distribution. The diagram shows the normal standard distribution, in which is the mathematical or theoretical distribution. Every score has an equivalent score in the normal distribution that can be used to calculate the exact percentage of scores. In order to give the percentage of scores between any 2 points, scores need to be converted in z-scores. The lastly is the correlation and regression. Correlation and regression can be used to denote the association between 2 quantitative variables. Both has similarities and differences. The similarities is that both quantity and the strength of the relationship between 2 numeric variables. It differentiates in a manner in which the correlation is a single statistic, whereas regression produces an entire equation. Geometric design. Back to kindergarten, we go from the earliest age we are taught to recognize shapes. Mathematics and art are related in a variety of ways. Geometry design is primarily studied to get a practical guide for measuring lengths, areas, and volumes. The use of geometry in our daily lives provides handy concepts. Just like other forms of arts, mathematics can be used for several reasons: to create the design of a building, age shape, height, structure, basic, at a construction blueprint. Mathematical system. Mathematical system has the following 4 parts: undefined terms, defined terms, axiom and postulates, theorems. Undefined terms. In mathematical system, we come across many terms which cannot be precisely defined, but in modern mathematics, we accept certain undefined terms. The general point is to facilitate the development structure. Example given are point, plane, number, and variable line. Defined terms. A defined terms in geometry, we have several undefined terms which are the point, line, and plane. From all these three undefined terms, all other terms in geometry can be defined. Axioms and postulates. Axioms are self-evident, which are common to all branches of science, while postulates are related to particular science. Both axioms and postulates are assumed to be true without any proof or demonstration. Theorems, a statement that we arrived at by successive application of the rule of application to the axiom and statements. The list of all possible theorems is infinite.